Hey everyone, this is Finn, and in this tutorial I'm going to show you how to create simple 2D movement with Unity 2D. First, I'm going to create a floor. I'm going to right-click on my hierarchy, create a new 3D object, cube, and then I am going to move it to the bottom and scale it out. Then I'm going to delete the box collider, and after I remove that component, I'm going to add a box collider 2D component. Since we are working in Unity 2D and with 2D objects, we definitely want to keep our 2D colliders. Now I'm going to name this cube floor, and I'm actually going to give this floor the layer of floor. So I'm going to click on this drop-down menu that says default right next to where it says layer over here in the inspector, and then I'm going to click add layer. This will open up the tags and layers menu, and where the next available layer is, for me it's user layer 8, I'm going to click and type floor. Now I'm going to click back onto my floor game object, go over to the layer drop-down menu, and I'm going to select floor to set the layer as floor. Now I'm going to create our player. I'm going to right-click and create a 2D object, sprite. I'm going to give this sprite a default UI sprite. So click this icon that's a circle with a dot inside, and click UI Sprite. Now we want to scale it by 5 by the X and Y axes. Now I'm going to rename this sprite Player. I'm going to right-click on the game object in the hierarchy, create empty, and I'm going to name this empty game object Eyes. While selecting the Eyes game object, I'm going to right-click, go down to 2D object and sprite. We are going to rename this sprite Eye, and then choose a sprite for this sprite renderer to render. This time we are going to choose the knob sprite. Go down here to where it says additional settings. We want our order in layer to be 1. So that it is in front of our body. Then we want to change the color of our sprite renderer to black. And now let's scale down our eye to 0.25 by the X and Y axes. Now I'm going to double click on this eye game object so that it brings me closer. And now I'm going to press Control D with that eye game object selected. I'm going to use my move tool to move this eye over here. I'm actually going to grab onto my eyes game object, the parent empty game object that is holding my two individual eyes. And I am going to move them this way a little bit. I'll just adjust the eyes. I want to make sure that it looks like our little box character is looking towards the right direction. So I might even scale those eyes down a little bit. That's perfect. I'm going to press Ctrl S to save. Now I'm going to click on my player game object, and we need two things. We need a collider, and we need a rigid body. I'm going to add a component, and we are going to add a box collider 2D. I'm going to change the size of the X value to 0.08 and the Y value to 0.08, and then I am going to tweak this edge radius to 0.12. Now you can see that this outer green boundary is where our collider ends, and it's actually got a nice curved edge just like our cube, our little 2D box sprite. Now we need to add a 2D rigid body. Let's press Add Component, and start typing rigid body. And let's click on rigid body 2D. Now, if I save my scene and press play, our character should fall and land on the ground. Very good. Now that we have our scene set up, we can start creating our player controller script. I'm going to make sure that I have my player game object selected. Let's go to the inspector and click Add Component. I'm going to type a name that I want to name my script, so I'm going to call it Playercontroller. And then I'm going to click New Script and create and add. Then let's click the 3 vertical dots at the top right of the Playercontroller script component, and then select Edit Script. First, we're going to start right under our public class with declaring some variables. Our first is going to be public float speed. We are going to be setting that in the inspector. Public float jump force, and private float move input. Then we're going to store our rigid body in a private rigid body 2D variable. Make sure that you are adding that capital 2D. We'll name it RB, that stands for rigid body. Now, let's go inside of our start function and store our rigid body 2D inside of our RB variable. RB equals get component. Make sure that you add the 2 angle brackets that come afterwards. This allows you to grab a component from this game object. We are going to grab the rigid body 2D. Get component is a method, and as we've talked about, methods or functions have the same parentheses at the end no matter what, even if they are empty parentheses. So you always want to add a starting and closing parentheses after a function or method. And just another reminder that function and method, those terms for C# are used interchangeably. Now, right before update, we are going to create a fixed update method. And that's because we have physics changes, and all physics changes need to be managed on a fixed update function as opposed to a normal update function. Here we're going to store our input into our move input variable. First, start by referencing your move input variable by typing move input equals input dot get axis, because we're going to be looking for an axis. We're looking for the horizontal axis. Make sure that you type that and surround that by double quotation marks, and then end that with a semicolon. Now we are going to move our player back and forth, left and right, depending on the horizontal axis, which are, in this case are the A and D keys, or the left and right arrow keys. Of course, right now we aren't actually moving. To actually create the movement, we're going to use our velocity. So type RB dot velocity to reach our rigid body's velocity equals new vector 2. Notice that we're not working with a vector 3, and that's because we're working in Unity 2D. Since we're working with a 2D view, we want to make sure that we are clicking vector 2 and add an opening and closing parentheses. Then for our x-axis, since this is how we move left and right, we want to type move input. Input.getAxis horizontal, that's going to return either a -1 or a 1, depending on whether or not you are pressing the left or right key. If you press the left arrow, then you are going to get a -1 return for that value, and if you press the right arrow, you are going to get a 1 return for that value. This is for the x value, so we will just put move input And then for the y value, we just want to type rb.velocity.y and end that line with a semicolon. Let's save this script and go back to our scene. I'm going to wait for this to load. And now I can add our speed. We don't want to add anything into jump force yet because we do not jump yet. So I am going to put 25 for our speed. Let's press play. Right now I move back and forth when I use the A and D keys or the left and right arrow keys. If I change my speed, I can move even faster. I'll change it to 75 since that's a little slow at 25. Another thing is wrong. When we move to the left, we are still facing the right direction. We want our player to be able to flip to the opposite direction when we are going the opposite direction. Let me show you how to do that now. Let's start by adding a couple new variables. Go up to under the public class and underneath all the variables you've already created. And we are going to create a private bool. In case you don't remember, a bool returns a value of true or false, so you can keep track of whether or not something or a condition is true or false. And toggle that back and forth as well. That's how we are going to be using that here. We are going to be creating a bool for facing right. And it's going to start out as true because that is our starting position. Then we are going to go down here under our update and create a new function. I'm going to type void flip with a capital F, a beginning and closing parenthesis, and then I'm going to open that method out with opening and closing curly brackets. The first thing I'm going to do is when this function is called, I want to toggle the value of facing right to be the opposite value as it is before this value is called. To do that, I'm going to type facing right to reference our variable, an equal sign, which is going to set our variable with a new value, and then that new value is going to equal the opposite, and that's what this exclamation mark means when you put it right before the variable. It is the opposite of whatever you put after it, so the opposite value of facing right. So facing right equals the opposite of whatever its current value is. So if you have facing right equal true at the beginning, which it does, after flip is called, you are facing left, so facing right is going to become false. The line after that, we are going to create a vector3 variable and call that player scale. And that's going to equal the scale of our object, which is transform, that references our transform component dot local scale. So we've got our game object's local scale inside of the player scale vector3. Now that we have our player scale, we are going to type player scale dot x, type an asterisk symbol, that is the symbol for multiplication, and then right after that an equal sign. That way we are multiplying to the current value of our current x scale. So player scale currently equals whatever our local scale for our game object was right before this line where we are modifying it. This is where we are actually going to be flipping our game object. To do this, we are going to multiply playerscale.x by -1 and put an asterisk after. That way, if the player scale is currently 4, after this, it's going to be -4. Now that we've modified that player scale value, we are actually going to update our current transform.localScale using that variable. So we haven't actually flipped our game object yet, but this is going to actually confirm that action. Type transform dot local scale, and that's just reaching our scale, our game object scale, and then equals, and we'll set that as player scale. Now we need someplace to call this function, flip. Let's scroll up to our fixed update. And press enter after our last line so that we can create a new line of code. I'm going to start an if statement by typing if. Then I'm going to open and close a set of parentheses, and inside of those parentheses I'm going to type facing right equals false. Remember that when you are setting a variable, you use one equal sign. When you are comparing a variable or seeing if it has a certain condition, then you use two equal signs. So if the facing right bool equals false, and that is an ampersand symbol. Let me zoom in so that you can see exactly what I'm talking about. It is your 7 key. It shares your 7 key on your keyboard. Right here, the double ampersand means and. So type 2 of those and symbols, and then move input is greater than 0, which means we are traveling right. If your move input is greater than 0, that means that you are traveling right. But if your facing right variable is equal to false, that means we haven't flipped yet. So I'm going to open up this if statement with an opening and closing squiggly bracket. And then I'm going to simply call to our flip function. After that if statement, I'm going to press enter and create a line underneath and type else if. This just means if the first statement wasn't true, go to this second if statement and see if this condition is true. Type opening and closing parentheses, and inside of those parentheses we are going to type facing right equals true. So if our facing right bool equals true, and two and or ampersand symbols, move input is less than 0, and the only way our move input variable could be less than 0 is if we are traveling left. So if our facing right variable equals true, but it happens to be false, that means we haven't flipped yet. So under these conditions, I'm going to call to the flip function again and press Control S to save my script. Go back to your Unity project and press play to test your scene. Now when we move around, we should flip back and forth. Awesome. Now let's give our character the ability to jump. Go back to your script, and we are going to add a few more variables at the top under our public class. Underneath the line that says private bool facing right equals true, type private bool is grounded, and that value is going to be false, but since by default the value would be false on a boolean, we're just not going to write that. We're just going to keep it like this and end it with a semicolon. This is the variable that's going to keep track of whether or not our character is on the ground currently. Helping us figure out if we are touching the ground currently is our public transform ground check. Then public float check radius. Public transform ground check and public float check radius are two things that are going to be helping us track how close we are to the ground. Next, you want to add public layer mask. What is ground? This is a layer mask we are going to set in the inspector after we create it, which we will in a moment, while we also create our ground check game object. But for now, we're just going to declare it. It's going to help us determine what is a platform and what's not. And now, to give you the functionality of a double jump, type private int extra jumps, and then right after it, public int extra jumps value. Let's go back to our Unity project. Select your player game object. You see you have a lot of different variables that we can set in the inspector now. We have ground check, which takes a transform, check radius, which we can set here, what is ground, which gives us a drop-down menu of all of the different layer masks that we can select. Luckily, we already created a layer. It is floor. Let's go ahead and set that now. What is ground is floor. So anything that is set to be the layer floor, which our floor game object is, right here. Now it knows what a platform is. It knows when we have landed. Now let's create our ground check game object. While selecting your player game object, right-click and create an empty game object by pressing Create Empty. Let's rename that ground check. And we're going to keep it empty, but to be able to see what we're doing, we're going to go over here, this little cube icon, click that icon, and then select one of these capsule-shaped images. Then what we're going to do is just use your move arrows with your move tool selected and drag this game object to the bottom of our player. This is just going to track our location for the bottom of our player. Normally it would be the bottom of the feet, but since this character doesn't have any feet, it is just a square box guy. It's going to just be at the bottom of him. Let's click on player and go down to the Playercontroller script. And let's click and drag the ground check game object into this box where it says ground check. And as you can see, it gives us this little icon that represents the transform component. It says ground check and then transform in parentheses. And that tells us that the transform of ground check is going to be the value of this variable, ground check. And since we have the game object inside of the player game object, we are going to have this move around with our player, so you won't need to reposition it. Let's go back to our code, and we'll start in the start function and type extra jumps, which is our private integer, equals extra jumps value. This resets the value of extra jumps to equal what we want our max value for extra jumps to be, and that is going to be set in our inspector. And our extra jumps variable is set right here. It's also going to be set when we touch the ground, and that's going to reset our jump counter. This is going to give us the ability to do double jumps, or triple jumps, or even quadruple jumps. Now let's go into the fixed update function, and at the very beginning, create a line that says is grounded equals physics 2D dot overlap circle. This is a function that is going to create an invisible circle. This is how we're going to detect whether or not we are touching the ground. Anything that overlaps inside of this circle is going to trigger the is grounded bool. Type a starting and ending parenthesis, and type ground check as your first parameter, check radius as your second parameter, and what is ground as your third. Keep in mind that specifying the layer mask that you want it to affect is not required, but it will give you more control over what is established as a platform. Oh, and the reason why this is underlined in red is because we need to make sure to not only type ground check, but to type ground check dot position. So is grounded equals physics 2D dot overlap circle ground check dot position check radius and what is ground are the three parameters inside of that overlap circle function. What that does is if it does overlap the circle, it returns true and is grounded equals true. If it doesn't overlap the circle, then it returns false. Let's scroll down to our update function. We're going to put some code in here now. First, we're going to check if the user is pressing the up key on their keyboard. Let's create an if statement, and inside of the parentheses, we're going to say input dot get key down, and then in parentheses after that, type key code dot up arrow. After that first closing parentheses and before the closing parenthesis there, we are going to type two and signs, and then extra jumps is greater than 0. This ensures that we don't accidentally subtract from our extra jumps if we have 0 left, because then we won't have any more to subtract. Then open up opening and closing squiggly brackets, move those down. Now we are going to actually do the upward movement by typing rb dot velocity, that is our rigid body's velocity, equals vector 2 dot up times jump force. After that line, we are going to subtract from our extra jumps value by typing extra jumps and then 2 minus signs and a semicolon. After that if statement, we are going to create an else if statement, and then in parentheses, we are going to type input dot get key down. In parentheses after that, type key code dot up arrow, just like before. And then after that, you want to say and with 2 and symbols, extra jumps equals 0. And then we're going to include a second and is grounded equals true. So we are guaranteeing that we are also on the ground. Open up that else if statement with 2 squiggly brackets. And then inside of there, we are going to type rb.velocity. If you want to, you can go ahead and copy and paste the line from before, but I'm just going to manually type it again. When you're a beginner, it really helps for you as well to type your code instead of copying and paste. rb.velocity equals vector 2 dot up times jump force. And this time, since our extra jumps equals 0, we are not going to include the line that subtracts from our extra jumps value. Go back to your Unity project and make sure that you have your player game object selected. Go down to your Playercontroller script component, and where it says jump force, make sure to change that 0 to a 5. And your check radius to a 0.5. For now, don't add any extra jumps. We are only going to want our player to be able to jump once before it's grounded again. Let's save our scene and press play. Now our player can jump. If I wanted to be able to double jump, I can add one extra jump in our extra jumps value. I'll change this 0 to a 1, and now I'm going to press play again. If I try to do it more than that, it won't let me.